Everybody. So this is the first public Peggy. There's a little bit of alliteration there. The first public Peggy development meeting, and we're going to be talking about. Oh, here, one more person. And today we're going to be going through sort of introductions, a design outline. So I'm going to talk about how Althea Peggy is designed and how we have the repos laid out. Um, and answer any questions, and hopefully try and organize some contributions for those of you interested in contributing, and go ahead and get sort of a status update for those that are just here to see how things are going. So yeah, let's see. To get started, I think it would be great if at least people who are interested in contributing could 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 introduce themselves, give their name, organization if applicable, and a component they're interested in working on, or just straight up an interest in Peggy. And as for how to get the order down, I guess we're just gonna have to let it be chaos here because I don't think people's orderings are consistent across browsers.
Hi, I'm Ethan. Yeah, I'm from Cosmosm, Confio, and I'm very interested in Peggy. I think you've done an amazing job on the Ethereum side. I'd love to see how I could help out on the SDK side.
Cool. Hey, Deborah. Hey, Zaki. Um, let's see. Anybody else, or do we have a lot of people who want status updates? Because I'll be happy to sort of describe the system, and I can just go into the next steps if nobody else wants to introduce themselves.
Yeah, hey, this is Jack Zamplin from Akash. We're interested in using pegged Ethereum assets as a medium of exchange. And also, I'm interested in Peggy development as well. Looking forward to it, Justin, and thanks for the update.
Cool. Thanks, Jack.
Hey, I'm Marco from Interchain GmbH. From my side, I'm just mostly interested in contributing, kind of helping set up Peggy.
Cool.
What up, Marco?
Hey, so for those of you just joining, we're doing introductions, and if you could give your name, organization if applicable, and a component you would like to work on, or sort of interest in Peggy, feel free to introduce yourselves. Obviously, not making it a mandatory thing, and also this meeting is being recorded for reference of those of you who have just joined.
I'm Vanessa Pistrito. I work at Agoric, and we are interested in Peggy for bringing the Ethereum assets into our environment. We're exploring a few use cases, and so we're excited to learn more today. And contributions we'll have to revisit maybe in the next call.
Cool. Thank you, Vanessa.
I'll just make a quick intro. Tarek here from Promise and working with Inclusion as well as Unified DAO. Unified DAO is interested in working and bringing Peggy implementation to the Cosmos Hub, but also to really get awareness and build awareness for Peggy in many of the other chains that might be able to have assets cross-chain across Cosmos Hub. So focused on product marketing and go-to-market for Peggy.
And I'll just add, I'm James from Secret Foundation, and we're very interested in bridging to Ethereum with Peggy. Secret Network is all about secret tokens, and Secret ETH will be an important one.
Cool. Thanks. Thanks, James and Tariq. I think we're going to go ahead and wrap up introductions, and I'm going to get into answering most of the questions y'all probably have, which is sort of a quick design primer on how Althea Peggy is assembled, what its timeline is like, and what the sort of key components are that we're going to need. So yeah, I guess I should say first and foremost that that we're focusing on a very simple design and a very simple feature set with the Althea Peggy branch, and I outlined this a little bit in the blog post that we first announced Althea Peggy development in. Um, so how should I put it? The peg zone concept, at least in the Cosmos ecosystem, has for a long time involved the idea of a zone with little or no stake of its own that is then connected via IBC to other zones and governed from other zones. This is a complicated problem, and it's still a sort of a research problem on top of the actual, design issue of just building a bridge. So Althea Peggy does not explicitly attempt to address this cross-zone governance problem. Not because we don't think it's worthwhile, but because we don't think that it is the right thing to focus on while we don't have the foundations that we need. So what we're working on is a very simple bridge that will not function trust-wise unless the native token has value greater than or equal to the value in the bridge. If, for example, you were to put 10 million in DAI into the bridge and the validators were to only have $1 million staked in value of native token, it would obviously be more valuable for them to steal all the tokens out of the bridge. And we're not working on a cross-zone governance system to solve that. And in fact, that's why we have a separate branch on the Cosmos Peggy GitHub, because the main Peggy repo is occupied with solving that problem. And it's incomplete, but it's also of a different security level. So we are targeting a security level that is essentially validator trusting with Althea Peggy. And that is simpler to build, and once we're done, these components can be integrated into the higher trust level Peggy master branch. And we can eventually bring a independent peg zone, is I guess what I'll call it. Or unstaked peg zone, low stake peg zone. Actually, independent is not the right word since it's explicitly being governed by another zone. So anyways, that sort of context out of the way. So the major components of a working bridge are the Ethereum contract, which needs testing, and probably some feature extensions for generic ERC20 support, but is otherwise done. So the biggest execution risk when it comes to our design for Peggy is being able to efficiently have all of the validators perform a full weighted vote using their stake. And then have that uploaded to the Ethereum contract such that the Ethereum contract holding the funds is actually decentralized and efficient. We identified this as the highest risk component and worked very hard to do that first. So I wouldn't call it completely out of the way, but we have solved most of the major problems there. And at this point, we can say with a very high level of certainty that the problem is solvable and the resulting outcome is cheap enough. What is still being worked on is the logic on the Cosmos SDK side and the logic on the relayer side. So we've really worked hard to keep the design simple here. So we're not doing anything fancy with signing. We're not doing anything fancy with oracles. And to sort of explain that, I guess I'll give an example where we go through the entire working flow of the bridge. So the validators decide that they want to update the validator set on Ethereum. Some client sends a message saying, hey, the validator set should be updated. The validators have a sort of special relayer we call the validator daemon that takes their Ethereum key, signs against the current validator set, and publishes that as a message so that it's stored in the chain store. Once all the validators, or greater than 66% of them, have signed off, you have just a bunch of Ethereum signatures sitting in the chain history, and a relayer can simply query these signatures, assemble them, and present them to the Ethereum contract. The Ethereum contract then goes and verifies these signatures, and updates its validator set. Now, there's a lot of optimizations in there. You can see the blog post for more details or ask questions later. But essentially, that is how the validator set on Ethereum is updated. We plan to keep this cheap by virtue of not doing it unless about 1% of the power on the Cosmos chain has changed, which should reduce it to once every couple of days. And it costs, somewhere between, when we originally designed this at 6 GWay, it cost 25 to 50 cents. Now it's going to cost somewhere between $10 and $20, depending on if you're at 200 GWay or 300 GWay. Although, if you wait until the late evening, you could theoretically do it for 100 GWay, but I digress. So that is the method by which the validators update the validator set. There is no need to observe Ethereum. There's no need for the Cosmos chain to actually know anything about what validator set the Ethereum chain is currently running with, because that's a problem for the relayers to make sure that all these validator sets are played back. Because obviously you can play them back at any time. And the only constraint is that you have enough funds in Ethereum to submit them, and that you want to submit them. So there's sort of an unstated assumption there that the relayers are incentivized to ensure that the Ethereum contract never gets too far behind the active validator set on the chain. And I think this assumption is pretty safe because it only takes one defector. Any one person can submit these updates, and they're not ruinously expensive. So for transactions, the most complicated part of Althea Peggy is actually a Peggy bridge mempool. And this is just a state machine that is once again progressed by sending a message, transaction, whatever you want to call it, on the Cosmos chain. Somebody sends a message, hey, I want to send these assets over to this Ethereum address. And then that sits in the store until such a time as somebody says, hey, give me a batch of Ethereum transactions. And at that point, the validators will sign the highest fee transactions that are in the store, that are in the mempool on the chain. And then a relayer can take this batch of transactions and submit it on the Ethereum side. Now, you'll notice here that we have a lot of messages and a lot of abuse of on-chain storage in order to really simplify the design here. There are no proofs. There is no complicated relayer schemes, and in fact, in order to simplify Oracle schemes, every validator is already running their own specialized relayer. We call it the validator daemon. I think I mentioned this before. That just does Ethereum signing, and the same binary is also observing the Ethereum chain through a Ethereum node that it is assumed that the validator trusts. So what this means is that since every validator is observing Ethereum, they can all for themselves decide what's true. And whether or not a transaction batch is valid is decided when somebody when a validator daemon observes on the Ethereum chain that X number of confirmations have passed after a batch has been submitted, it submits a message on the Cosmos side and says, hey, this batch is passed. And when 66% of validators agree, those transactions are cleared from the queue on chain, and the funds are burned and everything's finalized. So in this way, there's actually no trustful relationship for the Oracle. So there's no game theory to think about there. It's literally just, did your validator see it? Did your validator not see it? And yeah, that is really the grand total of the design. There's a lot of little details to focus in on and such. Um, but the long story short is that we are trying to make a very compact, very robust bridge design that we can ship as quickly as possible. So now to get to the details I'm sure a lot of you are interested in, and that is that at the current development pace, I expect that this will be um, production ready in 3 months. And I'm going to qualify production ready with the usual things in the blockchain world, meaning that it's going to be running on a testnet, ready to submit actual transactions to Ethereum, have no fundamental design flaws which would preclude it from being secure. This does not, of course, preclude minor design flaws, issues, various potential vulnerabilities. And how should I put it? We, Althea, intend to launch our own zone running Peggy pretty much immediately at this point because we don't have a huge amount of risk for our bridge use case. So I am giving a disclaimer, but I'm also saying that we expect to have sufficient confidence in it to at least give it a go. But we're definitely not going to put our life savings in there right away. So now, whether or not there will be an audit at this point is yet to be whether or not there will be an audit at that point is yet to be decided, and yet to really be planned for. But right now, that is the scope of the work. Yes, other key points is that this bridge design is good for arbitrary ERC20 from Ethereum to Cosmos and back. It does not allow us to take Cosmos assets and send them to Ethereum. That's actually not that much more complicated. I expect it would only take another month, two at most. But once again, we're trying to sprint on the very minimum viable product right now. And then finally, sort of more nuanced state of where development is right now. We have the Ethereum contract in a good state, as I've already mentioned. We are we are working. Well, I personally am working on the relayer binary and the signing that it needs to do, and that sort of fundamental stuff. And we have the valset logic in Cosmos SDK is written. What we need to write is the transaction batch handling logic inside of Cosmos SDK, the relaying logic in the relayers, and obviously actually integrate everything together and launch it as a testnet. We also need to add support for secure key storage, as most validators are probably not going to want to hand their relayer their Ethereum private key on the command line because you can be slashed for losing that. So I think that's a good summary, and I'd like to open it up for questions about the design. And don't be afraid to ask anything, because if you're thinking of a question, chances are several other people have it. Did I just lose everybody?
No, I'm here.
Okay, cool. Well, I mean, there's two senses of lose. Did I lose them in the sense that I talked too fast? Or did I lose them in the sense that my TCP packets are no longer reaching their computers?
Um, so Sam just posted a question in the chat, but I have a different question.
Okay, well, I'll answer Sam's first. Will validators be able to run ETH-like clients? And the answer is yes. A parity Ethereum-like client is capable of answering the requests that you need to make. I know because I run one. Well, I run them at scale for Althea, in addition to full nodes. But you're going to have a few issues with the delay of the response, especially if you're looking more than 100 blocks back. It's like a Three Stooges episode when you ask for an Ethereum full block. All of the nodes are like, I don't have it, somebody else has it. So you could be waiting upwards of 30 seconds to get that block request completed. Good news is that it's cached once it's in there, and so if you just keep asking for it, eventually you will get it. And this is actually one of the reasons that we're bringing. So we're writing the relayers in Rust to bring a lot of Althea's, how should I put it? A lot of our proven software over, because we essentially write small router boxes that do this. So we're taking our tooling in order to handle things like clients being slow and Ethereum nodes being very dumb. They're very dumb. There's lots of unique problems there. So short answer to your question, yes. Long answer to your question, yes. So yeah, Zaki? You're muted.
You mentioned slashing, and is that slashing on the Cosmos SDK side, or is that slashing on the Ethereum side? And where does that all happen?
Okay, yeah, cool. So that's slashing on the Cosmos SDK side. And so I talked with Chris Goes a while ago about this, and we discussed what would be good ideas for slashing conditions. And a slashing condition for having your Ethereum private key revealed. So as a validator, you register your Ethereum private key and attach it to your validator signing key. And when you submit a message to the blockchain that is signed with your validator signing key, a message to the Cosmos chain that is signed with your validator signing key and contains an Ethereum signature signed with the Ethereum private key, of which you submitted the public key to the chain and attested that it was yours. That is how you actually build the signatures that are ferried over to the Ethereum contract. So if that private key is revealed to the chain, you are slashed, that private key is invalidated, and you have to submit a new Ethereum public key signed with your validator private key. And this is very analogous to the slashing condition that already exists for validators losing their private keys, as far as I know. But I think that actually kicks them out of the validator set, which isn't necessary in this case, provided their validator key, their Cosmos validator key, has not been revealed. There are no other slashing conditions, and yeah, there are no other slashing conditions required to make everything work. And in fact, this slashing condition is optional because I don't. It really depends on how big of a deal losing control of the bridge is for your chain, which is always going to be a sovereign thing that's sort of up to the operators.
Cool. I'm also add one point because I had a talk with Justin some days ago. The word validator keys is getting confusing here. There are two kind of keys for validator. One is the ED 25519 private key used to sign Tendermint blocks, which is not being used here. The other one is the val opera key. It's often called operator key, which is the SecP 256K1 key, which is used to create the validator. It actually has control of the validator account, which was actually Cosmos SDK key. So that's stored in your Cosmos SDK key ring, not in some hardware signer of Tendermint, which actually makes it much more accessible to you. The keys signed are those. Just to clarify, that was confusing for me for a while.
Yeah.
In fact,
thank you.
in fact, I would actually propose that you don't need necessarily that key. I would say a validator, maybe more secure, is that key may want to be put one place, and you don't necessarily want that on some hot relayer box. And you could, for example, imagine just having the validator operator key authorize, say, this public key of Ethereum, this public key on Cosmos are my representatives, and use those in the relayer, and have those be kind of somehow stored on chain as representatives, which would allow you to use a different key as val oper and in a relayer. I'm not sure if it's unneeded complexity, but it could be considered that way. But anyway, these are all Cosmos SDK keys, not Tendermint keys.
Yeah. So yeah, we've actually considered some of this like key abstraction for the relayers and such. And I think it's probably a good idea, and it's not that much extra complexity, but I'm going to be pretty ruthless at keeping the complexity down for this first proof of concept. Because clearly
Yeah,
the priority here is to ship.
it's not a must for the proof of concept, but we would need that to deploy that on the hub. Like,
Okay.
we can.
You would need it for the hub? Okay then.
Yeah,
That's
we
not
can't.
terribly hard though.
Occlusion runs a
Is
multi. Like our operator key is a multi-sig. It's impossible to like program that into
So
real
it's
life.
impossible
There's
to
an
like hand a
example.
private key to someone.
Yeah, there's also like there's an example of building this abstraction. The for their oracles uses this same abstraction where you delegate a key.
hmm Yeah, I think we would just modify the I think we would just modify the message where you submit the Ethereum key. You would just also submit a public key, and there's no issues. Submit a Cosmos public key. Um, yeah. So let's see. I think Jack had a question or a statement.
So I was thinking about subkeys in this feature, and I don't know what timing on subkeys is, but it sounds like it might help with this issue.
Yeah, you can probably do something with subkeys. I just spent like a day doing HD wallet stuff. Anyways, but yeah, it's definitely possible. Um, right now, I'm gonna try and sort of get this running and then see what's ergonomic for the validators. Um, rather than now, on the other hand, if somebody wants to show up and help contribute or outline a flow that they think will work well for them, that would be great. Um, and I guess we're gonna try and get into like contributions and sort of what work is available, um, and how I would like people to interact with that. Um, if nobody has any more questions about the design, and don't be afraid to just ask me to say things again, because because I know that I talked a little fast. Oh, looks like we do. Okay. Are there significant? Okay, so to read Lee's question, is there significant implementation difference needed for Peggy on the hub? Does Althea have willingness to build production level Peggy on the hub while funded from community fund or other entity? Um, so to answer your first question, is there significant difference needed for Peggy on the hub? Fundamentally, I don't believe that there is much, if any, software difference needed for Peggy on the hub, except the hub may want a specific, easier upgrade path. Um, and now, so I should phrase this carefully. We are willing to build production level Peggy for the hub, depending on exactly what the hub wants. We may require additional funding to do so, like exactly what sort of upgrade path they want, and the testing and the support of that. And obviously there's sort of the cat herding of getting everybody to signal that they want it. But from a more general perspective, Althea the organization wants Peggy to run the hub. In fact, we want as many people to run Peggy as possible because of the nature of the design, which reduces costs via batching. A larger volume bridge is universally a big advantage across the board. So any opportunity there is to create bridge volume, we see as an advantage for us. So we're not trying to be the only peg zone. We don't want to be the only peg zone. We are going to run our own bridge just because, I feel like that's fair if we're building it and we're not willing to run it. That's bad. So we should be willing to run it. And also so that we can sort of reduce the risk for the hub and knock out as many of the kinks as possible, and have our own backup just in case there's ever problems with IBC or whatever. We are designing a Cosmos zone for telecom, and in telecom you never have one of anything. So that's sort of a golden rule. And I think that answers your question pretty completely. I'll tack on one other thing here, and that is that I personally am really tooling obsessed, and my goal is that deploying Peggy should be very easy. There should be none of this I'm not sure if y'all have ever looked into deploying like a major Ethereum contract setup, like something like Maker or one of these bigger contracts. They're often extremely opaque and they don't have one button deploy procedures or million button deploy procedures. And in fact, things like Aragon, generally only one person ever knows how to deploy it in production at a time, and only for a couple of weeks, because the deployment automation is just not. Uh, it's how should I put it? There's a focus on contract development rather than ease of deployment, which makes sense when you only need to deploy it once. Um, but for Cosmos's environment, where we're dealing with a lot of sovereign chains, one of my big focuses is that it should be easy for a chain to spin. It shouldn't be much harder than spinning up a base Cosmos SDK chain to spin up a peg zone. Um, and that means scripting for the Ethereum contract deployment and an easy spin up mechanism. So yes, I would, and the reason I wanted to say this is specifically because an easy upgrade path or an easy bootstrap path that the hub might want, I would really like to build that also for the larger community, so that it's easy to build a sovereign peg zone. So now that I've said entirely too many words on this subject, I am going to open it up for questions, for any more questions or statements anyone has, and then we're going to talk about exactly what tasks are open and sort of how contribution will work. Cool. So, let's go into open tasks. Essentially, things can be categorized in three ways, which is Solidity, Cosmos SDK, and Relayer. Currently, I'm still working on the foundations of the Relayer, and if another Rust developer wants to come in and work on and work on secure signing key integration. I think Zaki has already talked about getting somebody from Occlusion to try and help out with that, so that we're not using keys passed on the command line. That would be great. Next, for Cosmos SDK, the main task would be starting the validator, would be starting the transaction batch logic. You can find exactly where that, you can find this logic in the state machine in notes.md on github.com/cosmos. Here, let me just pull up the link for everybody and put it in the chat. .com, Cosmos, Peggy, branch, Althea Peggy. And there's a file called notesmd that actually has a lot of the nuanced details of what it takes to send messages. Yeah. So we need so ideally, to speed things up, Cosmos SDK contributions on things in that notes file would be deeply appreciated, which includes, state change stuff. Then for Solidity, we need the contract works. It's got basic integration. It's got basic unit tests, and we're working towards integration tests. But it would be really great if somebody could come in and test it exhaustively. Jahan is on leave right now, but when he's back, that's what he's going to be doing. So I don't think that's going to bottleneck us, and would not be as useful as Cosmos SDK contributions at the moment. And then, oh yeah, one other thing on the Solidity front, if anybody really wants atoms on Uniswap, which is what I like to call sending Cosmos assets to Ethereum, then we're going to need some ERC20 integration work with the Solidity contract. Jahan will have time for that at some point, but that's going to push that timeline out a little bit depending on his leave schedule. So yeah, and then when it comes to the relayers, I think I'm going to be working on that mostly solo for the next couple of weeks, other than key signing stuff. So that's everything. Ideally, I would say we would get 3 people full time on this. We don't really need more than that. Anything more than that is likely to get to be too many cooks in the kitchen. Um, and that's sort of the situation. So, any questions, comments? Oh, yes. I forgot contribution details. So, we have a channel in the Cosmos Discord. Pound, pound, pound symbol Peggy. And if you want to contribute, at me there, jkilpatr, or just at here if you can't find me. And I will be happy to go ahead and review pull requests or just answer questions about development or where things are. And likewise, I'll be trying to discuss daily what I'm doing there and keep doing updates and keep doing updates during the stand-up every Monday. So cool. I think that's everything. Does anybody have any questions on that or like how they can contribute?
It's a brief question. I looked at the note stuff, and the batch logic you described includes stuff like fee ordering and stuff like that, which I do not see in the notes.md under tx bash process. There's a lot of details in it seem to be missing in terms of working in that
I
side.
think we noted, yeah, Jahan and I had a really long conversation about potential starvation attacks, which is where you would send a bunch of let's say you send a bunch of transactions with a 1 cent fee and it costs $1 to do even the basic ERC20 transaction on Ethereum. And then you go and say, hey, I would love a transaction batch of all of my bunk transactions. And since batches have to be submitted, and since batches are inclusive, they could take a transaction that they wanted to censor and put that into the bundle as well, and essentially keep it from being useful until somebody submitted another batch. And the logic there is complicated. But the solution we've decided is that transactions are always submitted, is that you request a batch and you do not add, and the validators, well, the on-chain logic decides what order the transactions are put in, and it just does highest fee to lowest fee. So in this way, you can't maliciously build a batch. For a while there, we were going to let people cherry pick them and really see if we could build a fee market around that, but it's just not worth the trouble.
Okay, it's not. You should add this to notes.
That's going into the notes document. Thank you for letting me know. I will put it in there.
This is what I'm interested in looking at and reviewing. The other detail is those fees. Are they on in Atoms, in Ethereum, in the ERC20 token on Ethereum? Because if we're on a native token on Chain X, whatever, let's call them Atoms for now, but they're probably Althea tokens. And the other side, Ethereum, we're paying the fees principally in the Ethereum token. And actually, the ERC20 token, if you're covering 100 ERC20 tokens, right, you can pay 2 of those to the contract. But how do you? Sorry, too much noise in the background. I'm sorry.
No, don't worry about it.
But then the point is, how do you know what the value is? Because my 2 ERC20 tokens might be worth 1 ETH or 0.0001 ETH. So it needs a lot of knowledge of actually the current exchange rate on Ethereum.
Yeah. So how we solve? So okay, 3 things here. 1, we're going to pay. So fees will be denominated in the asset that you are withdrawing. So like if it's a batch of transactions of DAI, because batches don't mix ERC20 well, they can, but right now I don't want them to. So let's say you are denominated. So let's say that you have a batch of DAI transactions. Transaction message.sender on the Ethereum side will receive all of those fees in DAI. So when you send your bridge request on the Cosmos side, you include whatever fee is necessary to get it onto the Cosmos chain to send that message over there, which is normally 0 on Cosmos chains right now. And then you add in your and the fee field on that message over on the Cosmos chain represents fees paid in the asset that you are withdrawing. And this way, the fees are paid out on the Ethereum side, and it's really easy to figure out who. It sort of solves the whole problem of who submitted the transaction, because otherwise you've got a whole new Oracle flow where people have to watch who submitted the transaction on the Ethereum side. Who submitted the batch on the Ethereum side, and then try and reward them on the Cosmos side, which is not hard, but also not necessary. There's one other component to this question. Could you repeat your question again? Because I know I'm missing part of it now.
I think that makes sense. Just saying. So if there's a batch there, there's total fees of 100 token, whatever, or let's say 20 token, and I decide to submit that transaction on Ethereum, and I pay my large gas in ETH to get that in there. Great. Now I've done that. Good for me. I can then claim those ERC20 tokens as payment, right? But maybe depending on fluctuating exchange rates, ERC20 tokens may be more than enough to pay the gas fee, or maybe way, way too low. So it's unknowable when you create a batch whether or not the total fees that you can maximize are whether or not they're enough to cover the Ethereum gas cost, right? Because they're dominating one fee and the fee is paid another one, and the market for Ethereum is also changing, the fee market there. So it's too many variables to predict.
Yes, it is not completely predictable. We would hope that any asset that we are relaying has a stable enough price, and that batch creation to batch submission is quick enough that this isn't a big deal. But this actually comes up to one of the reasons why I do not want to mix assets in batches, because this way, because in this way, let's say that food token has an arbitrarily unstable price. Like literally, people are just losing money in Uniswap by sending the price to $10,000 and then 1 cent, and then $10,000 and then 1 cent. And if batches are all of uniform ERC20, the failure of that batch to be submitted will only halt assets of that type. And I think that that's reasonable and acceptable, given that most assets do not have such radically changing prices. And hopefully relayers would simply, we will design a relayer that takes a look at Uniswap, will observe whether or not it's worth it to make the exchange, pad the price significantly enough that you're unlikely to have a price fluctuation during the 10 minutes you're trying to submit it that's large enough to be a problem, and then that's that. And I think that's acceptable. And also, this outlines that ideally the relayer will have like an auto liquidate option where it will where as soon as it gets its rewards, it sells those rewards for ETH. I'm a big believer that the default provided tooling should be good. So we're not going to be doing any so we're not going to be publishing a relayer that is just like, hey, fill this with ETH and let it run. We're going to be trying to put enough ergonomic features in there that anybody can run it and reasonably not bankrupt themselves. Otherwise, we're likely to end up with no good relayers.
Great answer. Thank you very much. This video will be invaluable.
Yeah, thank you. And thank you for your questions. They are insightful, and they're a good way to get out just how much behind the scenes discussion has happened on this design, because it's a lot. For all that you try and keep it simple, nuances always pop up. So yeah, I think that's everything we need to cover today. And if anybody has any questions, they can PM me on the Peggy, on the Cosmos Peggy Discord, Peggy Cosmos Discord, whatever you wish to call it. And all y'all have a nice day.